All right. We're in section 3.3. We're going to talk about properties of logarithms. All right, guys, let's get going. Properties of logarithms. So the first thing we're going to talk about is the change of base formula. So our calculators will only calculate log base 10 and the natural logarithm. So log and ln. So our calculators will only calculate those two. Well, sometimes we want to find the log base 2 of something. We want to get a number for that. Log base 2, log base 6, whatever. Our calculators don't do those calculations. Our calculators only do log base 10 or log base e. So we have a formula for finding the log of any base of a number. So we're going to say that the log base a of x, if we want to switch to log base b, is going to be log base b of x over log base b of a. So we want to switch to a different base. This is the formula that we're going to use to find our change of base. So if we want to calculate a number, we want to find the log base 2 of something, we can use the log base 10 or the natural log. So this is going to be log base 10 of x over log base 10 of a. And that would give us the same answer as if we did the natural log of x over the natural log of a. So the only logarithms that we can do on our calculator are base 10 and the natural log. So if we want to figure out the log of another base, we have to use this formula. So let's take a look at a couple of examples using the change of base formula. And then in a little bit we'll talk about why it works. So let's say we want to calculate log base 5 of 18. So we want to get a number for log base 5 of 18. We can't plug that into our calculator because our calculator doesn't do log base 5. So we're going to say this is the natural log of 18 over the natural log of 5. Or we can do it either way. We could do the log base 10 of 18 over the log base 10 of 5. And when we calculate the log base 10 of 18 divided by the log base 10 of 5, we can do those in our calculator. Or the natural log of 18 divided by the natural log of 5, we can do those. And we get, for an approximate answer, about 1.7959. I just included some more decimals. So our calculator will calculate these. It won't calculate this. But this is how we convert. So let's do another one. Log base 2 of 42. This is the natural log of 42 over the natural log of 2, or the log base 10 of 42 over the log base 10 of 2. And if I plug that in my calculator and calculate, I get about 5.3923. Yes. So that was a good question, guys. Sonia just asked, So you just ask if we wanted to graph log base 5 of x, we could convert that to natural log of x over the natural log of 5, put that in your y equals to graph that function. So you can use a log base 10 in your graph to do a graph of the log of a function to another base. So let me pull up my calculator. So for this first one, I would do, as soon as this comes up, so I'm just going to hit, so for the first one I could say the natural log of 18 divided by the natural log of 5. And hit enter, and I get my answer. And I could do log base 10, so I could say log base 10 of 18, and divide that by log base 10 of 5, and I should get the same thing.
All right, cool.
So you just straight in the calculator just like it looks.
All right.
Okay? All right, let's look at one more change of base, and then we'll talk about some properties of logarithms. Log base 1/4 of 5. This is the natural log of 5 divided by the natural log of 1/4, or the log base 10 of 5 over the log base 10 of 1/4. And if I calculate that out, I get about 0.7124. So I'm just plugging it into my calculator just like it looks. Questions on change of base? All right, so a couple of clues. If the problem asks you, if the problem says find the logarithm without using your calculator, that means you're going to be able to get an exact answer. That means it has something to do with exponents. So it's going to be, if you're doing log base 2, it's going to have to do something with powers of 2. 2 squared, 2/3, 2 to the 4th, 2 to the 5th, something. So if it tells you to not use a calculator, you're not doing the change of base formula. The problem has to do with exponents. You use what you know about exponents. So that's going to be a hint that it's not change of base, that you're using exponents. All right. The properties of logarithms is what we're going to talk about next. So because we know that y equals log base a of x, if we write this in exponential form, that tells us that a to the y equals x. So this y, this logarithm, is an exponent. Logarithms are the exponents. So logarithm tells us the exponent that we have to raise our base to. Logarithms are exponents. So the rules for the properties for logarithms have to do with the properties of exponents. So all of these properties have to do with the properties of exponents. So we have three of them that we're going to talk about. The first one, log base a of x times y. or multiplying two numbers together. This equals log base a of x plus log base a of y. So logarithms turn multiplication into addition. Second property, log base a of x divided by y. Is the log base a of x minus log base a of y. So logarithms turn division into subtraction. And if we think of our properties of exponents, when we multiply numbers that are raised to exponents, we add the exponents. When we divide numbers that are raised to exponents, we subtract the exponents. So the rules for logarithms come from the rules for exponents. Log base a of x to the y power is y times log base a of x. So it turns exponents into multiplication. So when we raise an exponent to a power, we multiply the exponents. So it turns exponents into multiplication. And this last one is, and we'll talk about it in just a second, this is why the change of base formula works. And I'll talk about that in just a second. But before we talk about that, this first property of logarithms reminds me of a joke. So here's a logarithm joke for you guys. So Noah is on the ark, and the ark lands, and all the animals, Noah and all the animals get off the ark, and he says, okay, go forth and multiply. And everybody goes forth, and a little while later, Noah checks on everyone. Everybody's happy but the snakes. And the snakes say, we need some trees. So Noah says, okay, gives the snakes some trees. Noah comes back a little while later, a bunch of little snakes. The snakes are all happy. He says, what was the story? And the snake says, we're adders. We need logs to multiply. We're adders, we need logs to multiply. All right. So let's use this last property of logarithms, and we'll see why the change of base formula works. So we're going to say, listen up guys, got a little bit to go yet, stick with me. We're going to say that y equals log base a of x. This is the base. We need to change this logarithm. We need to do the change of base formula. I'm going to rewrite this in exponential form. So if I write this in exponential form, I get a to the y equals x. That's what we wrote up here. Now I'm going to take either the natural log or the log base 10 of both sides. So I'm going to say, I'll do log base 10. So I'm going to say the log of a to the y equals log of x. So I just took the logarithm of both sides. I'm going to use this last rule of logarithms and say y log base a to the y equals, sorry, the exponent comes down, so y times the log of a equals the log of x, and I get y equals log of x over log of a, and y was log base a of x equals log x over log a. And that's our change of base formula. So the change of base formula comes from this property of exponents. Using this last property of exponents. So the exponent here becomes multiplication. So I just wanted to show you why the change of base formula works. It comes from this last property of exponents. All right, the way we're going to use these properties of logarithms is expanding and condensing logarithmic expressions. So that's going to be the main thing that we use this for. So the first thing we're going to do, we're going to do an example of expanding. All right, so we want to expand a logarithm. So we have, for example, we have a log of 2x to the third times y to the fourth. So we want to expand this. So our properties of logarithms tell us that multiplication, what happens to multiplication? It becomes addition. So I'm going to turn all of these multiplications into addition. So I can rewrite this as log 2 plus log x to the third plus log y to the fourth. This one doesn't change. What happens with exponents with logarithms? They get moved to the front. They turn into multiplication. 3 log x plus 4 log y. So we're using the rules of exponents to expand this all out. The rules of logarithms. Rules of exponents, rules of logarithms, same thing. Questions on that one? Let's look at another example. Natural log of square root of x plus 5 divided by y squared. So the rules for logarithms tell us what happens to division. Can you help us out, Colin? What happens to division with the rules of logarithms?
Oh, so it becomes subtraction.
Becomes subtraction. So I have the natural log of square root of x plus 5 minus natural log of y squared. How do we say x plus 5 as an exponent? Square root of x plus 5. What is that as an exponent? X plus 5 to the what power? 1/2. And exponents, what happens to the exponents? They move to the front. 1/2 natural log of x plus 5 minus this exponent comes to the front, 2 natural log y. So to expand logarithms, we're just using our properties of logarithms to expand this out. Yes?
So would that be the final answer?
This would be the final answer. If it said to expand this logarithm, that would be the final answer. This would be the final answer for the first one. The last thing we're going to talk about today, condensing logarithms. So we're just going to go in the opposite direction. So everybody good with what we've done here? All right, condensing logarithms. So we're just using the rules to go the opposite direction now. So we're using the rules of logarithms to take some really long expression and condense it down. So we're going to condense 2 log x minus 3 log y plus 1/2 log z. So we want to condense this down into a single logarithm. When I have something multiplying in front, what can I do with that? What does that turn into? An exponent. So that's going to be log x squared. And I'm going to do the exponents first. So we have multiplying out here minus log plus log z to the 1/2. So all the numbers that are in front become exponents.
Would you put something to the 1/2? Is that square?
You could write it as a square root, yes. You could do it either way. So if you prefer, I'll just write it as square root of z. That's fine. All right, so subtraction. What happens to subtraction? It becomes division. So this is log x squared over y to the 3rd plus log square root z. Addition becomes multiplication. So this finally, as one logarithm, is going to be the log of x squared times the square root of z over y to the 3rd. So we're just condensing, using the rules of logarithms to condense this down into a single logarithm. Any questions on this? All right, let me give you some common mistakes that I don't want you to make. So common mistakes, and we talked about these a little bit with trigonometric functions also. So remember that the log of x plus y does not equal log x plus log y. We don't turn addition into addition, we turn multiplication into addition. Log of x minus y, same thing, does not equal log x minus log y. Log of x times log of y does not equal log of x times y. We don't turn multiplication into multiplication. And finally, log, now we turn multiplication into addition. And log x divided by log y does not equal log of x divided by y. Division doesn't turn into division. All right, so don't make these common mistakes. Questions? Okay. Homework. I have a worksheet, and there's some problems out of the book.
Sorry, dude. Hey, dude, sorry. Hey, sorry.
On the worksheet, do evens or odds. I figure you guys have a 4-day weekend, 4 straight days of doing logarithms. Isn't that awesome?